We no longer have any new transformations to learn about. So now we're going to learn about combining two at once. This is called the composition of transformations. This image that I found of a man doing parkour, looks like near the Bank of Hawaii, is doing what I consider to be a translation. So he's upright in this position. He moves upwards to the top of this fence or railing, so he's upright again. And that's just a translation. So he goes from an upright position to an upright position there. Then he does a front flip off of this railing, and that would probably be around some center of rotation, which looks like it's about right there. He rotates and lands upright once again. So in all three of these positions, he's upright. He's congruent the entire time. One of the compositions, well, dilation is not allowed to be one of the composition of transformations. We can use reflections, we can use rotations, we can use translations, but dilation is not allowed to be one of those because the final image must be congruent to the pre-image. One kind of composition transformation is called a glide reflection. It's a specific one where there is first a translation followed by a reflection in a line that's parallel to the direction of the translation. So here in this example, line PQ or line segment PQ gets translated upwards, becomes this red line now, this red line segment, and then it gets translated across line K, which notice that line K runs parallel to the direction of the translation here. After the reflection, then we get this green, well, I just colored it in red, but we get this green line segment, and the green line segment is the glide reflection of the blue line segment. Here's an example of a glide reflection. Triangle ABC with those vertices is going to be translated. It says x minus 12 and then y. That is the same thing as the if they gave us vector notation of negative 12, comma 0. So then we're going to afterwards reflect it in the y-axis, and we must do it in that order. If we're ever doing a composition of transformations, we're going to do them in the order that they tell us. In this case, it actually wouldn't matter, but in some cases it will. I know the solution is already graphed down there, but I want to show you the process of doing this. So first, I've labeled or set up my little table where I've got A, B, and C and their coordinates. And I'm going to A prime, and first I'm going to follow the translation. So I'm going to subtract 12 from all of the x coordinates. So I'm going to get negative 9, comma 2. And then for B prime, I'm going to get negative 6, comma 3. And then for C prime, I'm going to get negative 5, comma 1. Okay, and this first process was just following the translation. Now I need to do another process to do the reflection. Remember that the instructions or the rule for a reflection in the x-axis is keep the x-coordinate the same and change the sign of the y-coordinate, which I've written down in green there. Moving on then to do the reflection, I'm going to get a double prime, because it's no longer a prime, it's got to have a new prime to it. So I'm going to have negative 9, and then I need to change the sign of the y-coordinate, so that's negative 2 now. And then B double prime becomes negative 6, negative 3, and C double prime becomes negative 5, negative 1. Barely had enough space to do all of that. And all of that should be verified in the graph down there. Take a moment to make sure that you understood how I did each step before moving on to the next screen. Compositions of transformations like a glide transformation, again, they need to be congruent, the pre-image and the image, but that's just what we call when we do 2 or more. So there could actually be 3 or 4 transformations, and we might get into a couple problems that do that, but probably not very many. Okay, this next example uses the same problem from before, so all we're using though is the pre-image, so this blue triangle, but it's asking us to translate 4 units down and then reflect in the y-axis. So if we reflect 4 units down, that's going to be these instructions. So 0, -4 would be 4 units down, so follow that vector, and then we're going to translate in the y-axis, and those directions would be, well, I'll do them in green again. Change the sign of the x, and, well, hold on, let's not do, so it goes from x, y, goes to change the sign of the x, but keep the y the same. Okay, so let's set up the table. Okay, so I've set up my table. My coordinates for A are there. They're 3, 2. Again, I need to apply the vector first for the translation. So that's going to be leave the x coordinate the same, so 3, and then go down 4 units from 2, so that would be at -2. B prime is going to be at 6, and down 4 units from 3 would be -1. C prime is going to be 7, and then down 4 units from 1 would be -3. Now I need the double primes. So A double prime, B double prime, and C double prime are going to be found after following change the sign of the x coordinate and leave the y coordinate the same. So from 3, -2, I'm going to get -3, -2. From -6, -1, I'm going to get, or from 6, -1, I'm going to get -6, -1. And then from 7, -3, I'm going to get -7, -3. Notice that all of these coordinates are going to be found in the third quadrant, and since the pre-image was in the first quadrant, we would kind of expect that because it got translated 4 units down, and so all of it was in quadrant 4 at this point, and then after getting reflected across the y-axis, everything would have been in the third quadrant. So that kind of makes sense. Okay, it looks like in this example we're asked to reflect in the y-axis first and then follow a rotation of 90 degrees about the origin. So let's remember first of all that our instructions for a reflection in the y-axis is going to be x, y becomes opposite of the x coordinate and keep the y coordinate the same. And then the instructions for the rotation about the origin, 90-degree rotation about the origin, goes from xy to -y and then x. So use the opposite of the y coordinate for your new x coordinate and use the x coordinate as your new y coordinate. Okay, so looking at point R, for example, here down at the bottom of the screen I've set up my little table. So I've got point R at 1, -3. I'm going to follow the instructions for the reflection first, which says to change the sign of the x coordinate and leave the y coordinate the same. So that becomes -1, -3, just like in the graph. And then s prime becomes -2, -6, just like in the graph. So it got reflected across the y-axis there. And the next instructions are going to be to do a 90-degree rotation about the origin. So that's this part right here. That's going to lead us to R double prime, and again the instructions for that are up here. I'm going to use the y coordinate and change its sign, and that becomes the new x coordinate, so I get 3. And then I'm going to use the x coordinate as the y coordinate, so that becomes -1. And then s double prime is going to be found, again, following those instructions. I'm going to use the opposite of the y coordinate as my new x coordinate, so that's going to become 6, and then the y coordinate is the x coordinate, so that's going to be -2. You can see that the graph verifies my answers, but that's how you would come up with those numbers to know where to graph it in case you started out with just the problem as it's set up here and those instructions. And maybe you won't have a graph. Who knows? Hey, look, you don't have a graph. These two problems are about the only other examples that I could find that I would like for you to do these and have those ready to put onto your warm-ups for tomorrow.